All right, let's lock in. So in this video, we're going to look at how air gets to the lungs, how oxygen gets into your blood, and how CO2 goes out in the other way, how blood gets pumped around the body, how your breathing and your heart rate changes during exercise, and how to read a spirometer trace so that you don't get it wrong in the exam. But before we even go into it, it's important to understand the pathway of air. So when you inhale, air comes in through your mouth, your nose, and it passes into the trachea, then it goes down to the bronchioles and finally reaches the alveoli where gaseous exchange happens. And in gaseous exchange happens, the oxygen goes into the blood, CO2 comes out of the blood, then that oxygen goes into the blood vessels, it goes to the heart, and then the heart pumps it out in a process which we're going to look at, the cardiac cycle process. And then that is pumped out, it goes around the body, comes back to the heart, and then the whole process repeats itself. Okay, so we have a diagram here just so you see these different structures that make up the pathway of air. So you have your mouth, your nose right here, your mouth, your nose right here where air comes in, and the nose basically, it helps to make the air warm and moist, which is good for the lungs. So then it comes down to your trachea, which is your windpipe. The trachea, your windpipe that takes air down towards the lungs. Then you have the bronchi. So the bronchi is two tubes right here that takes air into each lung. Those are your bronchi, and then you have your bronchioles, which are these smaller branches, the smaller branches inside the lungs. And then finally you have the alveoli, these very tiny air sacs at the very end. When we zoom in, the alveoli look something like this. So fundamentally, that is the pathway of air. Now let's look at gaseous exchange at the alveoli. This is where you can really get easy marks because there's just some quick points that you need to talk about to just pick up those marks like clockwork. So gaseous exchange at the alveoli, think of it as a swap, right? Oxygen moves from the alveoli into the blood, and carbon dioxide moves from the blood into the alveoli. They're almost swapping places in a way. So if we have our oxygen molecules, let's say O2, loads of O2 in the alveoli, and then we have loads of carbon dioxide molecules in the blood vessels, CO2. These are gonna move in opposite directions. O2 is gonna move into the blood vessel, CO2 is gonna move into the alveoli, like we said. And this happens through a process known as diffusion. Diffusion being when gases move from high concentration to low concentration. So CO2 is moving from the blood vessel into the alveoli because there's a high concentration of CO2 in the blood vessels than there is in the alveoli. So it moves down the gradient. It moves down the concentration gradient. And oxygen, O2, is moving in the opposite direction from the alveoli because there's a high concentration of O2 in the alveoli compared to the low concentration of O2 in the blood vessel. So oxygen diffuses out of the alveoli into the blood vessel. And that is what we mean by diffusion. Again, it's the movement of gas from an area of high concentration to low concentration. And alveoli are very smart. You know, the body is amazing because alveoli is built in a very specific way to enable diffusion because it has certain features, certain factors that make it really great for gaseous exchange. And these are large surface area, moist thin walls, short diffusion distance, loads of capillarization, large blood supply. So loads of capillarization. This is just one capillary we looked at. This is just one blood vessel. Think of the alveoli as like having a bunch of capillaries all around it, just wrapped all around it, right? So that's why alveoli are really good at gaseous exchange. Okay, so boom, we've had the oxygen enter the blood supply. Now it's gone into the body, is moving around the body, is going to your muscles and your tissues. So again, let's have our oxygen here in your arteries, in your blood vessels, going towards your body and your tissues, traveling in the blood. And the really fascinating thing about blood is that it has these little molecules that carry oxygen. So these little molecules carry oxygen, and these molecules are actually proteins that we refer to as hemoglobin. Hemoglobin carries oxygen in the blood. Hemoglobin can also carry CO2. So hemoglobin carries oxygen. When it binds to oxygen, it becomes oxyhemoglobin. Oxyhemoglobin. So that's the protein that carries oxygen. So it carries oxygen, it moves towards the body tissues and your muscles. What happens here is another episode of gaseous exchange. So when you're exercising, when you're moving around, your body is releasing a lot of energy, and because it's working a lot, it's releasing waste like CO2, right? So you can already see where this is going. It's producing waste. So the concentration of CO2 in your muscles builds up, becomes high relative to a low concentration of CO2 in the blood vessels. So what happens? CO2 diffuses into the blood vessels. Meanwhile, oxygen is fresh coming from the lungs. So the concentration of oxygen in the blood vessels is high relative to a low concentration of oxygen in your muscles. So oxygen will diffuse down its concentration gradient into the muscles. So that is another episode of gaseous exchange that happens inside the body when oxygen is being moved around the body and being diffused into your muscles. All right, now let's look at the 3 different blood vessels you need to know. The 3 main ones. We have the arteries, which carry blood away from the heart. They have thick, strong walls, and they have a smaller lumen than veins. So the lumen is like the hollow space in the middle of the blood vessels. And the function of arteries is to carry blood away from the heart at high pressure. Capillaries are the next blood vessel we're going to look at. And capillaries are exchange vessels. So it's primarily where gaseous exchange happens. And they have extremely thin walls and allow for gaseous exchange of substances between tissues. And lastly, we have veins. So veins carry blood back towards the heart. They have thinner walls than arteries, and they have a wider lumen. They also have valves to prevent the backflow of blood, and their function is to carry blood back to the heart at a lower pressure. Okay, good thing we looked at the different blood vessels, because now we're going to look at what these blood vessels do during exercise to ensure that the working muscles have enough blood where it's needed. So during exercise, there's a process known as vascular shunting that occurs, and this is basically a process that comprises of 2 different mechanisms: vasodilation and vasoconstriction. So vasodilation happens where you need more blood flow to be during exercise, so your legs, your working muscles, and vasoconstriction happens where less blood flow is needed, so the less important or essential areas, such as in your stomach. So vasodilation would be, example, this blood vessel sort of widening to allow more blood flow, and then vasoconstriction would be this blood vessel narrowing to reduce blood flow. Okay, now very simply, let's look at the structure of the heart. You don't need to know too much about the structure of the heart, just some key structures that you should be familiar with. So the heart has 4 chambers. It has the right atrium, the right ventricle, the left atrium, and the left ventricle. And usually when we look at heart diagrams, this side is the right, this side is the left. So the left is actually the right and the right is the left, because we are looking at it from the perspective of someone. Imagine someone standing inside your screen and looking at you. We're looking at it from that perspective. So if we were to split the heart into 4 chambers, again, this is a very simple diagram of what, the heart doesn't actually look like this, but the right atrium is this chamber here. The right ventricle is the bottom right chamber. The left atrium is its top left chamber. Left ventricle is this bottom left chamber. So the top chambers, the atria, right and left atria, are chambers that receive blood. Ventricles, the bottom chambers, are chambers that pump blood. So the right side of the heart deals with deoxygenated blood, which is blood that is oxygen poor, deoxygenated blood that is going to the lungs. And the left side of the heart deals with oxygenated blood, which is going to the body. Okay, so deoxygenated, oxygenated, and other key terms are some key terms we need to know before we move on to talking about the cardiac cycle. So like I mentioned, oxygenated blood is simply oxygen-rich blood. Deoxygenated blood is oxygen-poor blood. Diastole is a phase of the cardiac cycle where the chambers relax and fill with blood. Systole is the phase of the cardiac cycle where the chambers contract and push blood out. So we can go back to our heart diagram here, our simplified heart diagram, to sort of show the cardiac cycle and the pathway of blood more simply. So we have our 4 chambers. So what happens is that blood comes in from the body through a blood vessel known as the vena cava. It's actually 2 blood vessels. We have the superior vena cava, which is on top, and the inferior vena cava, which is at the bottom, but you can just refer to it as vena cava. Blood comes in to the heart via the vena cava. It enters the heart. It goes into the right atrium. The right atrium is in a diastole phase, because for the blood to enter the right atrium, it has to be open and relaxed. So blood enters the right atrium, which is in diastole, and then the right atrium goes into systole. It squeezes and it contracts and pushes that blood down into the right ventricle. So it moves down to the right ventricle. The right ventricle obviously would have had to be open and in diastole to receive that blood, and then the right ventricle receives that blood, and then it goes into systole to pump that blood out into the lungs via the pulmonary arteries. So the blood goes out via this blood vessel here into the lungs, which is the pulmonary artery. So this blood vessel taking deoxygenated blood from the right ventricle to the lungs is the pulmonary artery. That blood, deoxygenated blood, goes to the lungs, picks up oxygen via gaseous exchange like we spoke about at the start of this video. It's now oxygenated, it's oxygen rich. It comes back from the lungs, oxygen rich blood into the left atrium via this blood vessel known as the pulmonary vein. Fun fact, the pulmonary vein is the only vein that carries oxygenated blood, and the pulmonary artery is the only artery that carries deoxygenated blood, because arteries usually carry oxygenated blood away from the heart and veins usually carry deoxygenated blood back to the heart. These are the two exceptions. Just a little fun fact to be familiar with. So that oxygenated blood comes back from the lungs via the pulmonary vein to enter the left atrium here. So it enters, and the left atrium is obviously in diastole to open up and receive that blood, and then it goes into systole, squeezes and pumps the blood down into the left ventricle, and then the left ventricle now pumps the blood out to the body via this massive blood vessel here, which is called the aorta. The aorta. So to simplify the whole process, we have diastole, which is chambers relax and fill with blood. We have systole, which is chamber contracts and pumps blood. Those are the two phases of the cardiac cycle. So the actual pathway of blood, to summarize it and simplify it, we have right ventricle, pulmonary artery, to the lungs, to the pulmonary vein, into the left atrium, then into the left ventricle, then into the aorta, and it goes out into the body, and then blood comes back via the vena cava, and the whole process starts again from the vena cava to the right atrium and then back to the right ventricle. So that is the pathway of blood. Usually it starts at the right ventricle, so just be familiar with it starting from the right ventricle. So that's the pathway of blood. And also another fun fact for you is that the heart chambers actually have valves. So we have blood moving in between different chambers, but just like veins, heart chambers have valves. Valves are like doorways in between each chamber to basically prevent the backflow of blood. Again, like I said, the structure of the heart for this course, you don't really need to know too much in detail, so you don't need to know what the names of the valves are, but just know that valves open due to pressure and then they close to prevent the backflow of blood. Alright, now let's look at 3 fundamental values that you need to know. We have cardiac output, stroke volume, and heart rate, and they all come together nicely to form this equation right here. So cardiac output, denoted by the symbol Q, is simply the volume of blood, or the amount of blood pumped from the heart per minute. Heart rate is a number of times your heart beats per minute, and stroke volume is the volume of blood pumped from the heart per beat. And they fit nicely into this equation, which means that if heart rate increases and stroke volume stays the same, then cardiac output also increases. If stroke volume increases and heart rate stays the same, then cardiac output increases. And if both heart rates and stroke volume increase, then cardiac output would increase by a lot, because heart rate is being multiplied by stroke volume. Okay, so a heart rate graph would look something like this: heart rate against time. And let's say this is your resting heart rate, just your regular normal heart rate when you haven't started exercising yet. And then you want to start exercising. Let's say you start exercise here. You want to start exercising. Before you even start exercise, there's usually a little rise in heart rate, which is referred to as anticipatory rise. So this is when heart rate increases just before exercise starts, often due to adrenaline and just the body preparing for exercise. So you then start exercise, and let's say you're exercising at different intensities. Let's say you're jogging, and then you sprint, and then you rest, 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 then you sprint, then you finally finish exercising. So you can see this is showing different exercise intensities on the heart rate graph, where heart rate is increasing and then dropping back, then increasing when you sprint and then dropping back when you're resting or when you're jogging again. And in these intervals where it's increasing, it's simply because there's a greater demand for oxygen in the body, so your body is trying to match that demand. Alright, now let's talk about mechanics of breathing at rest and during exercise. So we're going to talk about inhaling at rest and inhaling at exercise, and also exhaling at rest and exhaling during exercise. So AQA really want you to talk about the intercostal muscles, the rib cage, and the diaphragm when you are explaining the mechanics of breathing. So inhaling at rest, what happens is the diaphragm contracts and flattens, the intercostal muscles contracts, pulling the rib cage up and out, and this causes chest volume to increase, which causes the pressure of air in the lungs to drop, and as a result air flows into the lungs. Exhaling at rest, what happens is the diaphragm and the intercostals relax, the rib cage moves down and in as a result, and also chest volume decreases as a result, pressure in the lungs rises as a result, and air ultimately flows out of the lungs. During exercise, extra muscles get involved, and the extra muscles specifically are your pectorals, your sternocleidomastoid. So your sternocleidomastoid is a muscle that basically helps to lift the sternum and the clavicle to be able to expand the space in your chest cavity, thus increasing the volume in your lungs, reducing the pressure of air in your lungs, and allowing for more air to flow in. So that's going to be used more during inhalation during exercise. And then we have your pectorals, which are also used during inhalation and exercise. I'm just going to denote that here. Inhalation during exercise, your pectorals do a similar job of expanding the chest cavity, expanding the rib cage to allow more volume in the lungs, which causes the pressure of air in the lungs to drop even more and causes more air to rush in even more. The abdominals, however, is going to be used during exhalation at exercise. Exhalation at exercise. And your abdominals help to be able to push air out quicker, because when you contract your abdominals, it causes your diaphragm to move up quicker, and it causes a higher pressure of air in the lungs because your chest cavity becomes smaller, and as a result air gets pushed out quicker. And now let's look at how to draw and how to label a spirometer trace. But actually, before we look at that, these are the 4 lung volumes that you need to be able to define and that we're going to label on our spirometer trace. And what happens when exercise starts is that these volumes start to increase. So breathing rate increases, tidal volume increases, breathing frequency ultimately increases. So the way this all ties together is that because tidal volume rises, the extra reserves, so the your inspiratory reserve volume and expiratory reserve volumes, become less because you're using more of your capacity during each breath. Meanwhile, residual volume will stay the same because you can't fully breathe all of the air out of your lungs. It's always going to be a little bit of air left, and that's the residual volume. Now for the spirometer trace, this is what your spirometer trace would look like. We have your normal tidal volume, and we have huge peaks and huge troughs. So this right here, this normal peak and trough is your tidal volume. And then this from here all the way to the peak is your inspiratory reserve volume. And then from the bottom of the tidal volume here down to the trough is your expiratory reserve volume. And then the little bit of air left is your residual volume. Okay, that's it for this video. Don't forget to check out Super PE online for a ton of different revision resources that will help you to be able to master these topics and ace your exam. All right, see you in the next video.